Hi, my name is Tiana and excuse my stuffy nose. I just had a cold, but this is my protein project, and my protein is acetylcholinesterase, and it's also known as an enzyme that breaks down acetylcholine into acetate and choline. So it stops signals from being repeated, and it breaks down acetylcholine after the message has been sent to the muscle cells. So the enzyme is normally found in between the synapse of the nerve cell and your muscle cells, which is found in animal cells. So yeah. So this is my active sites. This is going to be the anionic site. This is going to be the estric site. And then this is my acetylcholine. So try to explain this in the best way possible. But okay, so the yellow represents I'm missing a yellow here. But the yellow represents hydrogen, and the pink represents carbon. This green right here represents nitrogen, and purple is oxygen. So yeah, same thing here. That's gonna be excuse me, that's gonna be oxygen, and then this is gonna be hydrogen because it's a hydroxyl group right here. And serine is found in the estric site of the enzyme because it helps break down acetylcholine into its hydroxyl group, which is represented here. So this is like the anionic site is mostly made up of negative charges, and it likes to attract positive charged molecules. So that's what happens with the acetylcholine. This right here, the nitrogen, is gonna be attracted to this negative charge anionic site. So when that happens, serine gives its oxygen over here. So if I had some scissors, I can demonstrate it for you. So when this happens, this oxygen gets delivered over here. So it becomes acetate and choline. So that's how that works. I hope I explained that in the best way possible. But also there's histidine 400 and glutamine 327, which is also located in the active site, and they're also both hydroxyl groups, and it just keeps it stable after hydrolysis. So yeah, so we have those two. But then serine will find a water molecule to replace the oxygen. So this will go back here, and then the process just repeats itself over time. So now we're going to get into the mutation itself. So this is going to be my nerve agent. And as you can see, everything is still the same for the most part. You have your hydrogen, which is yellow again. Pink is carbon. The purple is oxygen. Only thing that's really different for real is this right here, which is gonna be phosphate. The orange is phosphate. So the nerve agent will come down to the estric site, and it will bind to the oxygen molecule. So the phosphate bonds to the oxygen molecule. And I don't really want to cut it, so I'm just gonna show you how that happens. So when this happens, oh, also the oxygen right here is double bonded. So that's why I put it in green. But so when this happens, it blocks off everything. So the acetylcholine, when it's put back together, we're just gonna act like that's back right. But when the acetylcholine is back together, it can't, you know, get the signal to the muscle because this is blocking it. So that's how the mutation works. Excuse me. So in conclusion, acetylcholine, it's a polar molecule, and I feel like the limitations for this is that it really only shows the function of the active site and not really, you guys can't really see like the amino acid sequence and everything. But I feel like it's very important to see how the active site works anyway, being that the mutation is there to block it. So kind of you're seeing a visual representation of that. But yes, that wraps up my project on acetylcholinesterase.